Right, so we're going to continue looking at stationary points and just becoming more familiar with how we find them. Not an overly, not anything new, it's just about applying tools that we've already got to our understanding of stationary points and being really critical about what's actually going on inside the function. So question 8a in 6.1 has asked us to determine the coordinates. Now, be aware of the fact that they're asking us to determine the coordinates. That means we're going to need both a y and an x value for that. So you need to find the coordinates of the stationary point using calculus and then sketch the function with stationary points and intercepts. So before we do anything to deal with the sketching component, I'm going to look at using calculus to find our stationary point. So solving A, remember to find our stationary point, what we want is f dash x to equal 0. So before I can solve that, I need to find out what f dash x is. If fx equals x squared minus 4, x squared minus 16, I can see here that I've got a pretty tricky problem. I could expand it out, but that's pretty cumbersome. So instead what I'm going to do is I'm going to use my product rule, because I've got a function that I can derive times by a function that I can derive. So I'm going to let my first function equal u and my second function equal v. So f dash x will equal u v dash plus v u dash. Okay, where u, I'll just come over here, u equals x squared minus 4, and v equals x squared minus 16, v dash equals 2x, u dash equals 2x. That's convenient. F dash x therefore must equal 2x x squared minus 4 plus 2x x squared minus 16, which gets me, I'll take the 2x at the front, why not, x squared minus 4 plus x squared minus 16, which gives me 2x outside of x squared minus 20, sorry, 2x squared minus 20. That equals 0. So, I could take the 2 out, so I want to find the point the x value and that equals 0. I could factorise that a little bit more, but I don't see the value in that. I need to find out when that equals 0, and that only occurs when this thing here equals 0 or this thing here equals 0. So, in that situation, on the blue pen, either 0 equals 2x or 0 equals 2x squared minus 20. X equals 0 or 2x squared equals 20, x squared equals 10, x equals the square root of 10. Now that is a plus or a minus value. So how many stationary, sorry, I should address why that's a plus or a minus before I go any further. Okay, that's a plus or a minus because when you apply a square root to a function, you're basically undoing a squared. So if I put in, let's just say the square root of x equals 9. I'll deal with 9 because we know that the square root of 9 is 3. So x squared equals 9. The square root of 9 gives us 3. If I had negative 3 times negative 3, though, what would my response be? Be 9. So you have to acknowledge the fact that this value here, this square root of 10, it could be positive square root of 10 or it could be negative square root of 10. When I multiply those two values together, I'm going to get a positive value, so I need to acknowledge that. So I've got 3 stationary points, and they occur at x equals 0, x equals positive square root of 10, and x equals negative square root of 10. So now what I need to do is, obviously, I've found the x value, but that's not my coordinate. I need to find my coordinate. So to find my coordinate, I need my y value. So my y value is found quite simply by subbing these values back into my original function. So I'm just going to put SP1, okay, and that will occur at f negative root 10. Okay, and I shove that value back into my function, which is negative root 10 squared minus 4 plus negative root, negative root 10 squared minus 16. That equals, so negative root 10 squared is just 10. 10 minus 4 is 6 times 10 minus 16, which is negative 6, which equals negative 36. Cool. The same thing's going to occur at positive, but I'm just going to leave that out for now. I've got, I'll do that in red again, sorry. I want f of 0 equals 0 squared minus 4, 0 squared minus 16, and I get negative 4 times negative 16, which gives me positive 64. And then so that, I'll put these all at the end. And the third one, f of positive root 10 equals root 10 squared minus 4 root 10 squared minus 16, which equals, it'll be exactly the same as what we had before, negative 36. So my three stationary points, if I come back to my original question, I'll come back to A. My three stationary points occur at, I'll do them in blue. I've got negative root 10, 36, 0, sorry, that's negative 36, 0, 64, and root 10, negative 36. They're my three stationary points, and they are the points at which they occur. I'm going to now move on to number B, but I'll do that in the next video.